While the International Space Station is home for a lot of laboratory research on orbit, it also serves as a test bed for new technologies that could support future exploration efforts. One of those experiments is a European robotics research project that's known as Haptics, and it had its initial on-orbit testing almost a year ago in late 2014 and early 2015. The Expedition 42 commander, Barry Wilmore, was one of the astronauts who was involved with that, and he's with us this morning to help explain what goes on. Good morning.
Yeah, good morning, Kyle. Good to be here.
The word haptics, I looked it up. It says it's related to the sense of touch.
Okay.
In the training that you got for working on this experiment, how did they explain to you what it was you were trying to learn?
Yeah, we don't know where our operations will take us. Will it be robotic operations from a low orbit of the moon or Mars or another planet or asteroid or something like that? So right now, if you transit the time, if light travels 186,000 miles per second, so the transit time to Mars for signals to control things on the surface is roughly 20 minutes. So they'll send to the rovers that are there, they'll send a set of controls to those rovers, and 20 minutes later they get signals back where it moved and what it did. It's much better to have a crew that's right there in orbit around a planet. The signal, there's still a latency in those signals. It takes processing time for those signals to transfer through the different, boxes, signals, and semiconductors and whatnot. So there's a little bit of a delay even in that, but to be able to control those real time from orbit around a planet is kind of the synopsis of where we're looking to go with this technology. So yeah, you got to start somewhere, and it was last year, as you mentioned, that we started on orbit to start looking at these type of little delays and signals and whatnot, and how the one that's in control can affect the control of a vehicle with those little short latencies and signal delay.
Now, for the operations that you did, you were working with a tablet computer and a joystick. Describe what it was that you were doing, or what you were trying to do.
Yeah, well, basically the tablet, it was several different tasks, but the best way to describe the one task, the main task, was a tablet. It's sort of like an iPad, an elongated iPad. It would just have a ball in the center that would move a little different speeds and different distances and whatnot. And my task was to just follow it, because there's a little bit of delay built into the system intentionally. So my inputs to the system to follow this ball to see how well I could track it. So, and they of course took all the data and then analyzed it and see what my success or unsuccess rate was through the different trials that we did.
The background material says that a lot of this experiment, in some senses, is actually an experiment on the astronaut itself.
That's true.
More so than on the hardware, to find out how people in space can feel and react to feedback that they get through that joystick.
Yeah, that's true. Yeah, we mounted it to the bulkhead first, and did these different various tasks against the bulkhead, or with it mounted on the bulkhead, and started floating in proximity to it. And then we had another session later where we would actually mount it to the body and do the same thing with it mounted to us, and see if there was any difference in those different kind of setups. So like I said, following the signal, tracking it, going along, they analyzed the data. I think for me personally, I was the first one to do it. For me personally, I don't think there was a big difference. It was more of a comfort level for me. I'd prefer, just from the ergonomics of it all, to position it on me where I wanted it and work it from there, vice having to position myself in proximity to the box and work it like that, because I don't think the data was that varied between the two for me.
I wonder if that would be a difference to that if you were doing it in a 1G environment as opposed to a 0G environment.
Well, we did that, of course, in the training. We did it in 1G. I preferred in gravity to sit down and position the thing and sit there and do it, vice having it strapped to me. That was a complete 180. Yeah. It was a complete difference from what I felt like on orbit. So yeah, there's a difference.
Using that joystick and feeling that force back from it, was that particularly different than, say, flying the Canadarm2 with the controllers that you have in that way?
Yeah, you get pretty instantaneous feedback when you're flying the arm. There's not as much latency as we're built in, because like we were simulating signals to a planet that's however far away and coming back. So there wasn't a delay in that respect, or there's not that type of delay when you're working the arm. Plus you've got little bit different controls. Like I said, we're in the initial steps. How we'll do this, it's just a single joystick. Like I said, tracking task is what we were doing. So yeah, without that delay, the arm is very responsive, very predictable, and very nice to fly. This thing, not quite so much with the delay. It's built in because you're unexpected. What is the task going to be that we'll be doing? Yeah, driving a rover, picking up a rock. Who knows what other high gain task we might have before. So again, these were fairly high gain tasks that we were doing as we assess the person's ability to track with these little latent delays.
And the delays are mimicking the communications delay if you were
Correct.
doing this over a long distance.
That's correct.
Since you've come home, they have gone on to the next step, and crew members on board the station have used this setup to command a robot on the ground
Right.
at an ESA facility in the Netherlands.
Mhm.
How what is the point of that? Why would it be of value to have a crew member on an orbiting vehicle be able to command a robot on the surface of whatever they're orbiting?
Yeah, again, like I said, because you're there, there is latency in signal. If we're trying to control it from Earth, wherever you are, it's going to be long periods of time. You can't do it real time because we're talking on the order of a minute. You put in a control, you move it an inch, you wait, yeah, it moved an inch. I want to turn. We just can't do that. So when you're in closer proximity, like in orbit around the planet, then you can do real-time maneuvers with these vehicles or simulated vehicles or projected vehicles, and effect almost as if in many cases the person was actually there. We have a robot. Robonaut is actually attached to a rover over in Building 9, and that's kind of the concept with Robonaut is actually there, and you drive him around. You go and you control his movements from a distance. So that's on down the road as we progress, what we hope to get to.
And take advantage of robotics in order to be able to do
Indeed.
Exploration that we don't have to expose humans to.
Right. And of course, the human in the loop in close proximity to affect what you're trying to do. Much faster, much more efficient.
Very interesting. Barry, thanks very much for helping me understand that.
Yeah, thanks for having me here.
Astronaut Barry Wilmore was the commander of the Expedition 42 on the International Space Station and one of the first astronauts to perform the Haptics experiment on orbit.